For question number 13, this becomes a little bit of a problem because we can't factor this if we have sine on the one hand as well as cosine. However, here's what we know. We remember that sine squared x plus cosine squared x is equal to 1. So I can replace sine squared x with 1 minus cosine squared x. And you just need to be careful of the algebra here. So I'm going to copy this over. So we have 3 cosine x plus 3 equals 2 times the quantity 1 minus cosine squared x, which gives us, rewriting the whole thing because you're doing this neatly, 2 minus 2 cosine squared x. It definitely is quadratic, so let's set this equal to 0. So we'll move the 2 cosine squared x over, plus 3 cosine x, and let's subtract the 2, so plus 1 is 0. So this becomes 2 cosine x plus 1, and cosine x plus 1 is still equal to 0. Notice every single line is an equation. So then cosine x will be negative 1/2, or cosine of x is going to be negative 1. Well, cosine of x is negative 1/2 at 2 places on the unit circle. And I know that this is going to be a multiple of pi over 3, so one solution is going to be x is 2 pi over 3 plus, of course, 2 pi n. The other one is going to be 4 pi over 3, right down here, plus 2 pi n. And cosine of x is negative 1 right over here, so that's at x is equal to pi plus 2 pi n. So in other words, any odd multiple of pi. If you want to be kind of tricky, you could say x is going to be 2n plus 1 times pi. Will always give us an odd multiple of pi. And finally, for number 14, the only way you could do this is by knowing where sine and cosine are going to be equal. On the unit circle, that tells us that we've got an isosceles right triangle. The sine is equal to the cosine. So in this case, x has got to be 45 degrees, or pi over 4. And the other option is that we have something in the third quadrant where sine and cosine are equal, and they both happen to be negative, which is where x is 3 pi over 4. And right away I would notice that these are directly across from each other. So we can say that our solution is going to be pi over 4 plus pi times n. We'll take care of the 3 pi over 4 and also anytime we have a multiple and end up at either one of these spots.